in distribution you should know main thing is definition of this volume of distribution. If you take an example, I will say first example, then I will define what is distribution. Okay, consider you are giving 20 mg of drug by IV route. By IV route, if you give 20 mg of drug and you get a concentration of 1 mg per liter, 1 mg per liter. Considering this concentration as same throughout the body, how much liter will be required to contain 20 mg? It will require 20 liter, correct? In 1 liter 1 mg is there. For 20 mg 20 liter. Similarly, if the concentration is same thing, if the drug injected is 20 milligram and the concentration is 2 mg per liter, in 1 liter 2 mg, how much liter for 10 mg? 10 liter. Again same thing, if the concentration is 5 mg per liter, how much liter we will require? 5 mg in 1 liter, 20 mg will be in 4 liter. So how you are getting all this? Simply if you divide the drug injected to the plasma concentration, you will get the volume required. So this is nothing but volume of distribution. It is the volume that would accommodate all the drug in the body if the concentration throughout was the same as in the plasma. Throughout the concentration, if it was 1 milligram per liter, how much volume is required is known as volume of distribution. But see the term apparent, it is known, apparent is used. For example, if the concentration is 0.1, how much will be the volume of distribution? Now the volume of distribution becomes 200 liter. Is the body has 200 liter of water? No, it is more than total body water and more than the mass of the body. So hence the term, but there are drugs which have more volume of distribution, very large volume of distribution. Hence it is known as apparent volume of distribution, correct? Okay, it can be written like this. Okay, volume of distribution is equal to Q by Cp, dose administered IV divided by concentration. So what will be its unit? If the dose administered is given just in milligram and plasma concentration will be milligram per liter, what will be volume of distribution? Will be liters. If the dose given is milligram per kg, what will be the volume of distribution? Liter per kg. So it can be written just liters or liters per kg. Okay. Now I will give different scenarios. Consider if the drug is extensively bound to plasma protein. If the drug is extensively bound to plasma protein, where it will stay? It will stay inside vessel, because plasma protein will stay inside vessel. So this is the plasma protein, drug is bound to it. Okay, plasma protein, drug is bound to it. So what will be the volume of distribution? It will be approximately equal to intravascular volume. Intravascular volume. So if the drug is extensively bound to plasma protein, the volume of distribution will be equal to acicular compartment, which will be approximately 0.15 liter per kg. For this is, for example, for diclofenac, warfarin, which is 99% plasma protein bound. We will see which drugs are highly plasma protein bound in coming slides. Okay. Now scenario number 2. If the drug is lipid insoluble. What will happen if the drug is lipid insoluble? Does it enter inside the cell? Consider this is the cell. Does it enter inside the cell? No. It will remain outside the cell. So it will remain in extracellular fluid. Hence the volume of distribution which will equal to extracellular fluid. Approximately 0.25 liter per kg. Lipid insoluble drugs, water soluble drugs, example streptomycin, gentamicin, etc. Volume of distribution will be that equal to extracellular fluid. Now consider scenario number 3. If the drug has tissue specific transporters, there are tissues and the drug has specific transporter in the tissues, for that drug will enter. So if the drug has tissue specific transporter, consider this is the blood vessel, this is drug inside the blood, okay, and consider it has tissue specific transporters in heart, in skeletal muscle, okay, in liver and in kidney, okay. So the drug will enter into this, into this, into this and into this. So what will happen? The concentration here will start falling, okay. Once the drug enters, the concentration here falls. So concentration is very low. Though you have given some quantity of drug, but concentration will be very low. For example, consider the same thing, 20 mg was given. If the concentration is 0.1, 200 liter. So this is known as sequestering of drug into tissue. So if there is sequestering of drug into the tissue, drugs will have very large volume of distribution. See these points. If the drug has tissue specific transporter, drug gets sequestered in tissue, volume of distribution will be more than total body water or body mass. Examples are important, you have to remember, and all these have been asked. Digoxin has a volume of digoxin, don't need to remember this value, but it has high volume of distribution. Propranolol, morphine, consider the same example, 6 liter per kg. If the average man's weight is 70 kg, consider what will be volume of distribution, 420 liters. So it is not less. And one more important thing is, those drugs which get sequestered in the tissue, they are not easily removed by hemodialysis. Hence, if a question comes, drug not easily removed by hemodialysis, means if there are example of digoxin or propranolol or morphine, then you can mark them. High VD will not be beneficial in dialysis. Okay, next thing. Consider now fourth scenario. Consider if the drug is very high lipid solubility. If the drug has very high lipid solubility, the heart will pump the blood, correct? But you all know the flow of heart is variable. Some organs get high flow, some organs get low flow. So high flow organs, for example, brain, kidney. Brain, kidney will get first and more quantity of drug. Then the low flow organs, for example, muscle and fat, will get the drug. But see what will happen, the drug is reaching these organs, but their capacity is low, they will not take up all the drug, but the drug reaches first to them. But later the drug reaches to low capacity organ, low blood flow organs. Low blood flow but high capacity. High capacity means they are very bulky, they will take up all the drug, all the lipid soluble drug. So all the drug gets, so here the concentration of drug is there. Initially concentration of drug is like this, and once it reaches to these organs, it will be empty. So what happens, the drug gets redistributed from these tissue to this, again back into blood, correct? Because concentration is lowered, again back into blood because the concentration of drug is lowered. So this is known as redistribution. Okay, this is redistribution. It is because of low perfusion, high capacity sites, for example skeletal muscle, fat. Example of redistribution is thiopentane sodium. This has been asked, thiopentane sodium. This has been asked. Thiopentane sodium, it gets to brain, then from there it will gets redistributed to various tissues. So immediately the blood concentration falls, from again the drug is withdrawn from brain back into the blood, and concentration falls into the brain. Its action is terminated very rapidly. Similarly, diazepam. Diazepam, though it has a T-half of more than 30 hours, but its hypnotic action is only 6 hours. Why? Similar thing. First it goes to brain, then to other tissues. Other tissues take up whole the digoxin. In blood digoxin levels decrease. Blood diazepam levels decrease, and diazepam is redistributed from brain back into blood vessel. But what will happen if you give repeated and continuous administration? The tissue stores, like which was getting stored in muscle, fat, will get exhausted. Now the blood starts accumulating in brain also. So it will become more and more longer acting with coming time. Okay. So we have covered almost all points. Just for summary purpose, volume of distribution depends on plasma protein binding. High bound will remain in vessel. Lipid solubility, means high lipid soluble means they will get either sequestered into the tissue, they will have redistribution. Lipid solubility depend on lipid water partition coefficient, initial slides, or pK value of the drug. Why I am saying all this? Because these have been asked as MCQ. Volume of distribution depends on pK of the drug, age, blood flow, and some other option. All except, you will get confused. Hence, you need to know. Tissue specific transporters already finished. Now how age, sex, obesity will determine. As I was saying about tissue sequestration, where it was getting sequestered either in muscle or fat. This muscle or fat changes with age, it also changes with sex and obesity. Hence, age may also differ the volume of distribution. Sex, different male and female may be having different volume of distribution. Obese may be having different, lean body mass may be having different. Okay. Blood flow, is it dependent on blood flow? Yes, where I said in case of redistribution, high blood flow will get immediate, but later on the drug is withdrawn from the high blood flow to the low blood flow, high capacity organs. Now in pathological states, what will happen? For example, congestive heart failure, there will be change in intravascular, extravascular fluid, hence volume of VD will be changing. In uremia, cirrhosis, also because of plasma protein binding and many other factors, metabolism also comes into action. All these will lead to alterations in volume of distribution. Okay.